get that on record.
So let's have a look at this this problem. Our issue here is, so basically he's going to be putting $5,000 every year into an account that pays 4% interest compounded annually. And then how much is in the account at the end of 20 years? So, the simple idea, if there's no interest, it's easy. If there's no interest, it's 20 times 5,000. So it would be 100,000.
4%.
If there's no interest, it's 100,000. Now, the difficulty, if there is interest, you could add 4% to that, but all of the bits of money you put in don't get 20 years worth of interest.
Oh, sure.
How much interest does each payment get?
2019, 18, 17 perspective.
Now, the question is worded badly. This question is not good enough for an exam question because it doesn't say when the year he puts the money in. Does he put it in at the start of the year or at the end of the year? Does it say?
No.
So let's say he puts in 20 payments. We could agree on that. He either puts the 20 payments in at the start of every year or at the end of every year. Let's start off by considering that he would put each payment made.
So you're going to spell payment.
There you go.
I thought it was like faking his dyslexia.
No, spelling
So
it.
why are you actually terrible?
I told you it was bad. Okay,
Like an English teacher.
so if the payment is made at the 1st of January of every year, the first payment is put in the 1st of January, that will have how many years worth of interest?
0.
No. If you put it in, we're going to look at the sum in his account at the end of 20 years.
Okay. So that's 20 years.
So the first payment is going to be 5,000 times 1.04, and this has made 20 years worth of interest.
Mm-hmm.
To this, we're going to add, so we're going to make a sum. To this, we're going to add the second payment. How many years worth of interest will that get?
90.
90. The third payment, how many years worth of interest will that get? 18. ... The last payment goes in at the beginning of the year. How many years worth of interest will that get?
1.
1. So how do we calculate this sum? We could add them all up. We could do all 20. Is there a shortcut?
No, we don't.
Yes.
Oh, sorry. Your brains are switched off because you do know. What type of mathematics are we looking at here?
We're looking at a sequence.
We're looking at a sequence. What type of sequence?
A geometric sequence.
So we could do a geometric series.
Yes. Oh, you just use the formula, right?
We would use the formula.
The SN formula.
What formula would we use?
S of n equals forgot. Is it this one?
Formula booklet, yep. Find it in the formula booklet.
No, because it's just this each
You give up too easy and assume things that are within your abilities. What's the sum going to be?
So entering which final sequence.
Isn't it like the
U1.
U1 parentheses R minus 1 so minus
Is this series arithmetic or geometric?
Geometric.
Geometric. So So what's the sum of a geometric series? Or
Regular
sequence?
terms.
U1 or
What's U1?
First and first.
Okay. And then what's the interest?
4%, 0.
1.
What's the common ratio?
1.0.
1.04. What's n?
When 20.
Is it plus 1, minus 1?
Minus
So minus 1.
Minus 1.
Over.
Over.
Or, so 1.04.
Okay. Is this the sum?
Wait,
You have to make it equal to. Or no, you don't. You don't have to use
I
the
think so.
No.
Wait, no. It's meant to be R minus 1, no?
Yeah, so 1.04 minus 1 is
Oh,
0.0.
okay, so you're ready.
Okay, we've got a mistake here in this.
So don't tell us. Oh.
It's not a simple one. How many terms in this series that we're adding?
Oh,
20,
isn't it minus
20.
1? So you do 19? Something about n minus 1.
You're getting in the right direction. So the series doesn't have the n minus 1. Look at the formula sheet, it's to the n. What about finding the nth term, the formula for finding the nth term?
Oh, for the nth term you do r to the power of n minus 1.
So for this series here, what's the first term?
5,000.
For this series here, what's the first term? So here, U1 is 5,000. But here, our U1 is 5,000, 1.04. That's the first term. There. So if this is the series, this is the 21st term. This would be U2. U1 is missing from that sequence. So we could fix this problem by because if this is the 21st term, we need 21 terms. And then we take away U1 because we're not putting money in on the final day of the 1st of January after the 20 years. Yeah. This would give you the answer here. This would give you the answer here. Now, if you put the money in at the end of the year, you get a completely different sum. You've got one less amount of interest on everything. Putting it at the end of the year would make it easier for a geometric series because your first term is U1 now at 5,000 and you would just have 20 terms. So the problem is trickier whether you're paying it in at the first of every year or you're paying it in at the end of every year. Let's have a little look at how the finance solver works. Let's have a little look at how the finance solver. This bit's important. So get your calculator and your finance solver in your hand, but follow me through big time. We are going to look at the finance solver. We're going to have a nice new document. We're going to press menu 8 finance solver. Okay, so let's say we have one year. 1 year, no compounding periods or anything. What interest rate should we use? Should we use 4%? Use 4%. So, if we put in $100, how much will the future value be?
104, 108, 105.
That's simple interest. After 1 year, it's going to be 104, isn't it?
Mhm.
How much will it be after 2 years?
Oh, is it going to be 108.25?
108.2 something, isn't it? Let's have a look. So for 2 years,
Oh,
108.16.
okay, that makes more sense. So then 112.24.
Let's have a little look. Sounds like some good math there in your head.
Might be wrong.
It might be. It was pretty good there.
Oh, I don't know.
Yeah.
48.
Yeah, because you got to have a little bit from you got to have compounding of the first one twice, the second one once, and so on. So it's going to go like this. Okay. So let's look now at 1 year. We're going to have nothing in the account to begin with. And we are going to make a payment every year. So we're going to put in 100 every year. What will the future value be after 1 year?
Oh, it's going to be 100 because we just put it right.
It's going to
We
be.
put it at the end of the year.
It's going to depend whether you put it at the beginning of the year or the end of the year. So if I press enter here, did that go in at the beginning of the year or the end of the year?
The end.
End of the year. You have another option here at the bottom to say, does it go in at the beginning of the year or the end of the year? So let's check whether that works. Let's see if what we expect it to be this time.
104.
104.
But at the beginning, at the end, it's going to increase.
Okay. So for that last problem, let's see if we can solve it now. That last problem we were just working with. Where is it? Here. We're putting in 500, 4% interest, 20 years, and we're putting it in the beginning of every year. So the finance solver, we wanted 20 payments, 4% interest. We're putting in 5,000 at the beginning of every year, and the future value will be, there we go. It's not 100,000 lira, it's 154,000. That's how much interest we get.
If it doesn't say beginning or end, which one should we?
It will always say, usually it's very clear on the dates, it'll sort of say you put it in on the 1st of January, and payments are made on the 31st of December. So the end of the year is it's always based on 1st of January or 31st of December, and done that way. Makes it much easier for you. So let's do, what have we got now? Anmol decides to save for a yacht. He would like to try to have 1,000,000 lira at the end of 10 years. He saves every year in an annuity that pays 4% interest. Calculate how much he has to save. Is he saving at the beginning or at the end of every year?
We don't know.
We don't know.
Doesn't say. So let's say that the payment is made on the 1st of January. So we're going to go to the beginning of every year. Let's see if we can work this one out then with our finance solver. Have a go for yourself to begin with. Okay. So let's see how we're going to enter this one in. So N, with the N, follow me through on this one. You can work this finance solver in two different ways, and you'll see some of the examples in the book doing it differently. I'm going to explain how you should always think in my way, and I'm going to try and be very consistent. So N is the number of years, unless you're working with payments. So if you're working with monthly payments, N is the number of payments. So any question where you're using the finance solver, N is the number of years, but if you're making payments, make N the number of payments. Okay? So here we are, how many payments are we going to have?
10.
10. So it's also the number of years in this question. What's our interest rate? 4. Our present value?
Empty.
Empty. Well, how much are we putting in every year?
We don't know.
We don't know.
We don't know, so we want to...
Future we put 1 million.
Negative 1 million.
No, because we want to get that back. So
Okay. But also for the last
I
one.
always do it going into the bank, negative. Coming back from the bank, positive.
Okay. Because with the last problem, like what we received in interest was negative. That's why I assumed this would be negative as well.
Okay, let me just continue with this one. So we've got a future value of 1 million is what we want.
And at the beginning.
And we want to make sure that we are at the beginning of every year. So then we can calculate what the payment is going to be.
Yeah.
Now, so in your notes, you want to say that N is 10, I is 4, present value is 0, future value is 10,000, sorry, 1 million. Payments per year is 1. Compounding periods per year is 1, and the payment comes in at the end. Sorry, what is the short name for that? PMT at payment at beginning, isn't it? This gives us a payment of minus 800,807.4. Are we rounding that one up? 4, 5. So we get this. You'll get a negative answer. Always give your answer as a positive. So if you're getting a negative coming out of your finance solving, it's always a reason that the payment he makes, so always answer with some word. He pays 80.
He saves 80. How much he has to save each
Well, he
year?
pays. I guess he pays or he saves is better. 87.45 every year. So make that positive in your wordy answer. Mark schemes specifically say if the payment is negative, then mark wrong. Okay, got time for one last one. So Trinchi, I'm not sure how to pronounce that, has been left an annuity of 5,000 in a will. The annuity is for 5 years at 8% per annum to be paid out monthly. Find the monthly payments. So we'll do this one together to save time a little bit.
So what's the difference between annuity and inflation? Sorry, not inflation, interest.
An annuity is a payment made regularly.
Like monthly?
It's an actual payment. Interest is the increase on the amount in an account.
So if it is less than annuity means that you got more.
So what's
So you
happened
get
here?
money and then
What happens here in this question is whoever has passed away has put 5,000 euros into an account, and it's going to pay him a small amount of money every month for the next 5 years. So it's like, it's a little, instead of giving him 5,000, he puts 5,000 into account for the guy, and then gives him a small amount every year. It's much better with a young person. Instead of giving him 5,000, you put 5,000 in.
So it's like
an account.
sort of like a salary, basically.
Yeah, it's like a little salary.
Okay, that makes perfect sense.
Yes, it's a good thing to do. So how many payments is he going to get?
He's gonna get
That's 5.
12 times
Or no,
60
monthly.
payments.
He gets.
You can type it into the finance solver like this. It's 12 times 5 because it's monthly payments.
60 payments, 8%.
8%. Present value.
5,000.
So minus 5,000, we put 5,000 in. We're going to find out what the payments
So
are.
plan.
We'll leave that blank. What will the future value be?
0, all the way to 0.
0. How many payments per year?
Per year, 12.
How many compounding periods per year?
5.
It's
Oh,
so it doesn't say here in the question that it's compounded monthly, but we have to assume it's compounded monthly because the account balance changes monthly. Normally it would specify this. You can't have monthly payments and annual compounding, so it just doesn't work like that. When do the payments come?
we're not told.
They're going to come at the end of every month.
Does it say?
No,
Oh, okay.
doesn't specifically, but he's going to get a monthly payment at the end of every month. Makes more sense. Then at the end of the full period on the last one is when at the end of year 5 is when it's empty. The last payment comes out then. So he is going to get 101.38. So let's just type that one up. We get N at 60, interest rate at 8, present value is at minus 5,000, future value is at 0, payments per year, it's going to be 12, compounding periods per year, it's going to be 12, and the payment at the end of every year. This gives us the payment. Notice how the payment is positive. Remember, we always put money into the bank as negative. This time the payment has come out of the bank.
So the calculator shows like our pockets. If it's leaving the pocket, we put negative. If it's coming into our pocket, we put positive.
Yeah.
Okay.
Yeah. 101.38. So we'll get we'll get €100 a month for the next 5 years. That's nice.
Yeah.
That's nice.
Except for the fact that somebody died, but yeah, that's true.
It's what?
Somebody died.
Oh, okay, but that happens.
That's irrelevant to the math, I think.
Wait, sir,
But that happens.
if it's given negative, we always use it positive on our accounts.
Yeah. So homework for this session is exercise 10F. We are finished there for today.
Bye, Christian.